Question 7 is about polar coordinates. When we are doing this kind of question, I suggest you on the rough worksheet, you draw out the polar coordinates of different points. So this is what I've drawn. And point A, the coordinate of point A are 10 and 70 degrees. So about here, A. And then point B is 160 degree, so about here. And I think it's really important for you to identify this right angle. Angle AOB is 160 degrees minus 70 degrees, which is 90 degrees. So it is a right angle. And we have point C, and this forms a square, so it will be about here. So it can form a square, and we need to find the coordinate. By properties of square, you should know all four sides are with the same length, which is 10 units. And when we cut it in half into two triangles, the angle here will be 45 degrees, and similarly here is also 45 degrees. So we first find OC, and OC is equals to square root of AO squared plus AC squared. AO squared plus AC squared, which is square root of 10 squared plus 10 squared, which means 2 times 10 squared, so it's just 10 times root 2. So coordinates of C are 10 root 2 and 70 degrees plus 45 degrees, because we move here from here is 45 degrees. So it's 10 root 2, 115 degrees. Okay, so for question 7b, it asks us to write down all the possible polar coordinates of a point D such that OABD is a parallelogram. So the first answer we should write down is just the answer from part A, because we know square is actually a kind of parallelogram. It has all of the properties of a parallelogram. So that so if point D is at point C right here, it actually will form a square with OA and B. So a square is a kind of parallelogram. So this is our first answer. And to find the other answers, we first need to know that a parallelogram is actually made out of two congruent triangles, because by the properties of parallelogram, opposite sides are equal, and the middle line of the two are the common side of the two, both of the triangles. So it actually is SSS. So a parallelogram is actually made out of two congruent triangles. And notice this triangle OAB is actually an isosceles right angled triangle. So we know this is 45 degrees, this is 45 degrees. Here's 10, 10, and 10 root 2. So if we need to draw another point to make it an parallelogram, we can write it somewhere here. And to find the coordinate of this point, we first need to know the length of OD. Length of OD. Because opposite sides are equal, so length of OD is actually 10 root 2. And similarly, there's also a point here, point, and this one OD is still 10 root 2. It doesn't change. What actually changes is the angle. So B has the polar coordinate of 10, and okay, what's important here is the 70 degrees plus 90 degrees is 160. And then here, notice that this triangle OAD and triangle OAB are congruent, so their angles are the same. So here the coordinate of this point is 10 root 2, and then the angle is A is 110 and 160. So 160 plus this angle right here, plus 45 degrees. So actually it is 205. So I write down the second answer, which is 10 root 2, 205 degrees. Here, the length is still 10 root 2. The angle is B. This is also 45 degrees. B is 70 degrees, so it's just minus 45 degrees, which makes it 25 degrees. So the third possible coordinate is 10 root 2, 25 degrees.